Hello, everyone. This is Group 8 presenting our project for Digital System Design, SMJE2173. Presenting is Abdul Helmi Prasada and me, myself, Omar Wael Yassin Saladdin. This project is managed by our professor, Dr. Oichi. It's a guessing game, and we're introducing to step one. For our design of the game, we made two players and tried to guess the machine-generated number, which utilizes a 7-segment display, a random number generator, a finite state machine. The random number generator creates a number in the range of 0 and 99. As per the question, we had to do this for the machine to guess exactly between 0 and 99, and the player has to guess the number that is given by the machine. So the participants then input their guesses into the machine, into the finite state machine, to try and guess the number that was generated previously by the random number generator. If they guess the number higher than the random number, the machine will display higher. And if they display, the machine will display low if the input of the player is lower than the number. And for the correct answer, it will display nice as the you win phrase for the machine, as he has guessed the number correctly. The players take turns playing from the start. Player one plays and then goes to guesses and then goes to player two, then guesses, then goes back to player one, then guesses, then goes back to player two, back and forth until one of the players find the correct answer and wins the game. Going to step, as you can see for step one, we made a black box explaining how it works from the random number generator to the finite state machine to the states decoder and the 7-segment display. As a 7-segment display is used to display the phrases that are written in our machine, like low, high, displaying play, displaying nice. In the finite state machine, there's two buttons and other buttons for the players to guess the number and try to input their guess for the game. Going into step two, we will explain the state diagram that we made for the game. As you can see, from state, we have 6 states, which goes from state 0 to state 5. When starting the game, the machine generates a random number and displays the nothing state, which is state 0, and goes from state 0 into state 1, where the players start the game and the machine displaying play. So what state 1 is that it grabs the random number generator and starts the game for the first player. And then afterwards, the first player starts and guesses the random number, and it either goes to state 2 or state 3, depending on what the player guesses. It will go to state 2 if the guess is lower than the number, and will go to state 3 if the number is higher, if the guess is higher than the number. And also it will go to state 4, which is the win state, if the number is guessed correctly from the start. So after it goes to state 2 or 3, goes back to state 5, starts again for player 2. For player 2, he also starts guessing the number, and afterwards goes to either state 2, 3, or 4, the same way. So after it goes to state 4, which is the final state, after the win phase, where does it go? It goes back to state 0 to start the game completely and resetting the whole game again for the players to play again. Thank you. Next is Abdul Hilmi, and he will explain step 3 for our project.
Okay, thank you, Omar. In the step 3, we are discussing about the coding, how we built this machine, this guessing game machine. We start from, this is the top module, as you can see. We have the inputs here and the clock, the reset, the start button, the start buttons 2, the guess button 2, and also the switch. Switch is basically the numbers that input by the players, and also the output. The output of this machine will give the 7-segment display, where we divide it into 4 display to display phrases like low, high, nice, and play. And there is a wire like a random, which is the random number, the state, and the outputs will connect the state to the 7-segment. Now we continue to the submodules. The first submodules is the random number generator. It's generating the 7 bits number, 2 digits decimal number from 0 until 99, using the concept of the LFSR, or we know as a linear feedback shift register. How this works? So basically there is a stream of number, a binary number, and it shifts the numbers to one way, and in linear. And as it's shifting, the first binary that is leave it empty will be treated as a feedback, which the number will be the binary of the product of the binary store. This is we make to make it random, as random as we can. So the number will generate it's called a pseudo random number. Exactly. Then we proceed to the next submodule, which is the final state machine. This final state machine is control the states. As you can see in the state diagram, is state 0, where the display is blank. State 1, where the display is play. State 2, where the display is low. State 3, where the display is high, and etc. Here you see the input is the start button and the guess button. Also the random number from the generator and the guess number from the player. And the output will be the state, of course, the control. If you see here, the reset, it's acting as the negative H. So the start button, if the start button 1 is pressed, then it gives the machine to proceed to the state 1 from state 0. Then the player enter the guess number. After enter the guess number, the player press the guess button, and when the player press the guess button, the machine compare the guess number to the random number. So it will decide if it's higher, lower, or equal to the random number. Then it proceeds to the next stage. As we can see here, it's quite understandable. So we proceed to
We
the
move
next
to the next one.
submodule. This is the 7-segment display. We don't display any numbers in our machine. Instead of numbers, we display phrases like show here: play, low, high, nice, and blank. Blank is substituted
first
by
state.
the strips.
Yeah.
So we can see here all the letters, and all the letters is input by the 4 bits binary number. Where this 4 bits binary number comes, this will come to the next submodule. This is the state decoder. This state decoder is produce the signal from the finished state machine to the 7-segment display. So this state decoder outputs 4 bits number, binary number, for each state. So for state 0, it is to display all strips. It gives the inputs to the 7-segment as 3 decimal number and goes on until the state 5. And that's how we code our machine. And the final step is the waveform. This is a waveform. As we can see here, the reset first trigger to make it in the initial state. Then it goes to state 0 where it is strips or strip, and then the start button is trigger. Start button 1 is trigger. Then it gives the play display, and then the guess button is trigger. It gives low, which means the number guessed is lower than the random number. And you can see here the guess number is 30. So 30 is lower than the random number generated. Then, because of lower, we proceed to the next player. The second player press the start 2. Here, the start 2 is trigger. It proceeds to state 5, which display play, the word play. Then they input the number 55. When input the number 55, they press the guess button, and it shows the display high, which means 55 is higher than the random generated number. So the answer, maybe it's between 30 and 55. And then we reset the machine to make it back to the initial state. And that's how the waveform. And now I want to show you
the simulation,
the compilation and the simulation process, to show if there's no mistakes or no errors in our program. Okay, I'll share the screen. This one. Okay. This is our code in the Quartus Prime Lite Edition software, and we'll start the compilation. As you can see here, the process is running in the percentage and the task here, taskbar in the left. Okay, there's no mistake in analysis and synthesis. It means the syntax is all good, no error. Also the filter, place and root, the assembler, and the timing analysis. Okay, as we can see here, all good, no mistake, no error, which means our code is ready to simulate in the waveform. And when you can see here, we already prepared the simulation. This is the waveform. Can you see the waveform?
Yes, we can see the waveform.
Okay. This waveform,
wait 1 second. The waveform did not get shared because you're displaying the other Quartus. So display the waveform immediately, or display your screen. Up to you.
Okay, this.
Yes.
Okay, as you can see, this is our waveform simulation.
Yeah.
It's
Like
the same as the picture that I show you.
Exactly.
Okay, then we start the simulation. Okay, it gives the outputs, and we can compare to the picture in the slides and to the coding that this displays is correct. Yeah.
And the game runs smoothly, runs with no errors. So any players can come and play our game. I mean, it's up to them if they want to enjoy our simple game or not.
Yeah.
Exactly.
Okay, back to Omar. Thank you.
Yeah. So thank you guys for watching. This was Group 8 presenting. It was a simple game, but it took our efforts to build this machine. We are happy that it runs smoothly with no errors. This game is very nice to play. We made it for players to love games, for who loves games and they want to enjoy just a simple game, and maybe people will get into coding more because of this presentation we have done. Thank you. See you next time.